So I need to explain, I am from an insurance company. I do walk up and down. It's harder to hit a moving target, I've learned. It's part of the training of being an insurer. But I do work for an insurance company. Some people have some confusion over FM Global. We do approvals. We do research. We do a nice line in fire videos, if anybody's interested. But we are an insurance company, a property insurance company. But we're unusual in the fact that we're a mutual, so we're owned by our clients. And the other thing is we have a belief that the majority of loss is preventable. That's why people like me as an engineer get hired by FM Global, and I work in part of research to try and understand how to stop our clients having fires, floods, explosions, those sort of things. I'm going to talk about change and why we need research. Some people have heard me talk about this before. When I was preparing for this session, I was thinking about, well, how can I link research to change? Well, things are always changing. If I thought back 15 years ago, that was my phone. That Nokia on your left was my phone. It's a fantastic phone. You could do all sorts of phone calls on that phone. If you were really desperate, you could do text messages on that phone. It was pretty good at those as well. And people didn't understand, but you could connect to the internet on that phone. It was really clunky, but it was fantastic. And then about the same time as the last revision of our technical guidance called Approved Document B, some guy launched the iPhone. And the world changed. What a fantastic idea. On a Saturday afternoon now while I'm being tortured shopping, I can surreptitiously sit there, read a book, I can check the football results, I can actually check on the bank to find out how much my wife is spending. If you'd have asked me 15 years ago, did I think that was going to happen? No. But that's part of our story, and I'd link this now to our built environment. Our built environment is changing all the time, and fire is inextricably linked to our built environment. There are certain things that are happening out there. We're seeing a growing population, an aging population, urbanisation. Society's expectations of the built environment are changing all the time, and our government are changing their policies on different things that may impact fire. At the same time, we're seeing the rise of new building technologies, standards. How we use buildings today are different to how we used them in the past. Firefighting technologies are changing. Some would say we have fewer firefighters because of it. We have sustainability. I don't believe sustainability is evil. There are some consequences of sustainability that have changed the fire environment, and we need to take care of that. But my message is, all these things are evolving all the time. We need to sort of think about them and what we can do about that. For me, we can't stand still. It's part of our human condition. If I just take one example, the building on your left is how we're seeing warehouses today. Somebody is building a rack structure and then cladding the outside. That's a building. The racking that holds the goods that will be on fire if anything happens are carrying the outside structure of the building. Does anybody know what this building is on the right? That's an 8-storey timber-framed office that's going up in North America. We're starting to see a lot more people talking about timber-frame construction for everything. We're also talking about extending high-rise buildings at the moment in parts of the world by, we can't put steel up there, but maybe we could put a timber frame extension on the top of buildings so that we can put more people in to those existing buildings. Fascinating. Very fascinating. But my point is, we're always pushing the boundaries. We're always thinking about some of these things. What can we do next? People who know me as an engineer know I sit in meetings, I listen to people. I have a certain expression on my face. People ask me, what's wrong? I'm just thinking, okay? But what I'm normally thinking is, how can I use that? Could I do something different with that? Could I use that in a different way? And I'd say to most of you in the fire protection community, how many times has a client said to you, oh, I know you said I can only store to 13 metres. What if I made it 14? What if I made it a foot wider? You said I could only build with a certain footprint. What if I went bigger? That's the nature of the beast that we live in. Okay? Now, I wouldn't be an insurer without sort of saying that we have to check some of the claims of some of these people. When I say claims, I don't mean insurance claims, it's not a pun, but people out there make all sorts of claims about new products and new technologies. We need to have a format or a way of checking those. I wouldn't be an insurer without also saying, as we push the boundary and we want to do some of these things, there's not a case of risk. There's always risk out there. Life is full of risk. We can't get rid of risk, but we can do things to manage that risk. So I'd advocate to people that they need to sort of be thinking about, how do we do this? So for me, that's where research comes into this. Yes, that is the research station for FM Global, nestled in the woods in the US. And if you went inside, we do things like this. We burn things and blow things up to learn what can we do about it. This is a fantastic video if you watch it online. This all sort of thing that we can do inside. We store product up to about 15 meters. We get one of our trained arsonists to light the fire. We then watch how big the fire grows. And after about 10 minutes, this fire is at the top of that rack. And basically you're going towards that Raiders of the Lost Ark moment where the flame length is too long, it bends under the ceiling. You're at that critical point that if our trained firefighters don't knock that out, you're in real problems. Okay? The point is, unless you do some of this research, we can't give you the standards and the technology to protect some of these features. And that's one of the things we need to think about. So I'm just going to take you through some things that are publicly available from FM that I look at and say, well, they're interesting in terms of how research can help. Okay, I'm from a property insurer, but we do work for other people at times to sort of help. So this is a bit of research to look at what's the impact of sprinklers in a domestic setting. This is a domestic setting in North America. Somebody's looking at this and looking at the difference here. You set a fire in two buildings, one with, one without sprinklers, and look at the performance. What's happening? The unsprinkled building, you've got a 13 megawatt fire inside this room. You've probably got a 300 kilowatt fire inside the sprinkled building. The temperature is very, very small. You're probably not going to get much above 120 degrees C in that building if you're lucky. Because of the nature of the research that we do, we put a calorimeter over all of this, so we know what came off the fire in terms of toxic elements and everything. That's a publicly available report, but you need this sort of information when people are arguing with you. What's the impact of sprinklers? You need to be able to do that, and that's where research comes into this. Technology is moving on in other ways. There are questions from today. We've recently done some research on some materials that might look like aluminium composite materials to find out, well, which are good ones and which ones are bad. Some would say we've already done this, haven't we? Unfortunately, globally, I don't think we've done enough of this to understand how do we make good choices. I'd like to think that we will get to a point where, as an insurer, we'd be able to say to our clients, use non-combustible materials, and they would do that. But unfortunately, some of our clients, for other reasons, want to use other materials. We need to help them make good choices. A way of doing that is to use research to give them information so that they can make a choice. Some new technologies that are out there. Somebody this morning talked about lithium-ion batteries. Okay, if you own a Tesla, okay, you might say that, well, there's a battery in there. Most people think there's a battery in a Tesla car, which is a big lump of something. Actually, you'll probably find it's a lot of cells strapped together as an array. Okay, and we've seen some interesting developments around the world from fires within these types of batteries and these battery systems. So we've done some testing to look at, well, how do you protect those? What do those fires look like? What's the composition of the elements that come off these? And we have to remember, a battery is an energy storage device. Once you disturb the chemical elements in there, it keeps releasing that energy. That's what makes them very, very difficult to sort of put out. And this gives us some clues as to the future and what the future will look like when we have large battery arrays. Some people might not be aware of this. Sometimes you might see a new shipping container appear at a large plant you may visit. That may well be a large container full of batteries because they're storing energy. You go into a computer room these days, you might think, oh, they've got a new rack server. No, they've got a new battery array. So you're more likely to run into a number of these things in different parts of the world because we've worked out we want to store energy. But if we want to understand what the risk is, we have to do some research to test this. Oxygen reduction systems, okay, they can work in certain circumstances. They do have their uses. But you need to do some research to understand, okay, well, where's the edge of the envelope? What's a good system? What's a bad system? Again, we've done some research to look at this to say, actually, we may need to go to a lower depletion level of oxygen to actually make them effectively work in all circumstances. Okay? If you have a small enclosed space that you want to protect that has a lot of rare books in there, this could be a great solution. I'm not so keen on the idea of using this for a warehouse. Modelling. I have to do my piece on modelling because I come from a research organisation. When people talk to me about modelling, somebody gets their laptop out and shows me a model of a fire on a laptop. I'm sorry, you just can't do it too well with a laptop. You need a lot more computing power. This is several years' worth of work to model fire. This starts with somebody over here called Mr. Wang, who did a lot of stuff on the gas phase of fire. Mr. Chatterjee, looking at how does radiation and soot. Wren looked at sort of convection. Krishnamurthy sort of looked at parallel panels and said, how can we model that? That leads you to something that says we can model a rack storage array. Then, some poor bloke has to sit down and work out what does water flowing over a box look like? How is water absorbed in cardboard? And then looked at it and said, when we do some tests, do we get the same results? That allows us to do some large-scale modelling. And what that allows you to do, if this video worked, you can go online to have a look at it, you can look at the difference between performance of systems. Where's the edge of the envelope? What works, what doesn't? But please believe me, you need a massive computer to run some of these simulations, and they run for days. This is not something I can do on my tablet. So when somebody's sitting in front of you and telling you they're doing fire modelling, and this is why you're okay, please understand that it's a model of something else, but it's not a full fire model. But again, research doing this enables us to answer some questions. And lastly, just want to talk about smart sprinklers. We're again looking at the future of the sprinkler. It hasn't really changed in a hell of a long time. They've got bigger, we've put bigger holes in them, we've put fancier devices on them to make them operate. But what if we could make a sprinkler smarter? What if we could attach sprinklers, some sort of valve device and a computer together and look at how we deploy water into a fire? How can we look at something and say, how can we sort of knock out a fire earlier by using that combination? So there's some chaps back in the US who are looking at this on a regular basis because one of the issues we see in the future is we're going to have less water. And what water we use, which is very effective as a firefighting device, is going to need to be deployed in different ways. So this will be a way that we can see that it could happen. We have to be careful about the reliability of these systems. But you can imagine if you look at the growth of a fire, you know where the fire is. What if you squirted water at it very early to break that cycle? Okay. I realise I've sort of dashed through a number of issues because I've got this clock running at the front here that you can't see, but I'm on time. For me, I've dashed through a lot of things, but what I'm trying to sort of say on the basis of we're in a good spot as the sprinkler community because research gives us knowledge and allows us to have choice. It helps us answer some questions about our built environment. And it stops us crystal ball gazing all the time. It gives us real information. If there's one thing as a sprinkler community that we've got over a lot of other people is we've got that information and we've got that data. It's how we choose to use it to affect change. But we have the research, but we need to continue to invest in it. Thank you very much. This is the end of my presentation with my question. If you could direct research, what would be your focus for the next 5 years?
Can we just have a show of hands for this as well? Because the system's not working. We're just about to change part of it. So we have a show of hands once Tom's read out the question.
So question 1, fire protection strategies with minimum water usage. Would you invest your money in that? Combining detection and suppression technologies, or fire safety strategies for changing demographics, an ageing and disabled population? You decide, A, B or C, where you're going to invest your money for research in the future.
So we have a show of hands for A.
Even I can count that many.
That's 3 or 4, I think. And then B, majority. And C.
That's an interesting number.
Okay. The front seats.
Thank you very much.
Thanks very much, Tom.